we want to evaluate this definite integral. I is defined as integration from 0 to pi over 2 sine cube of x over sine cube of x plus cosine cube of x dx. Before solving this problem, we try to prove a property of such integration. So if I call this function f of x, then integration of f of x dx from 0 to pi over 2 is what we want to find. Now, we change the variable here to u equal to pi over 2 minus x. So in this case, du is minus dx. For x equal to 0, u is pi over 2. And for x equal to pi over 2, u is 0. So we change the variable x to u, and we find this integral. So integral I is from pi over 2 to 0. The limit of integration is reverse. F of pi over 2 minus u, which we replace for x, minus du, which we replace for dx. Now, if we look at this integral, we realize that by changing the sign here for minus du, we can also change the order or the limit of the integral. So this I is also equal to integration from pi over 2 to 0 f of pi over 2 minus u du. And because u is a dummy variable, we can replace it with x, and therefore I 0 to pi over 2 f of x dx is equal to 0 to pi over 2 f of pi over 2 minus x dx. Now with this property in mind, then we define I as 0 to pi over 2 sine cubic of pi over 2 minus x over sine cubic of pi over 2 minus x plus cosine cubic of pi over 2 minus x. And here we have dx. But we realize that sine of pi over 2 minus x is cosine of x. And cosine of pi over 2 minus x is sine of x. So I, therefore, is equal to 0 to pi over 2 cosine cube of x divided by cosine cube of x plus sine cube of x dx. Now we have another version of I here, comparing to the one that the problem wants us to find. So we add these two I together the original version, which is sine cube of x over sine cube of x plus cosine cube of x dx, and this new version that we just got here. And we add these two together and we get 2i from this calculation. And this would be equal to, we add those two terms to each other, the denominator is the same. And if I add the numerator, I get 1 for this ratio. So this 2i is equal to 0 to pi over 2 dx, or pi over 2. Integration of dx is x, and if we substitute the limit, we find pi over 2. So from here we find I, which is the integration we want to find, is equal to pi over 4.